Yeah, thanks. So, given the awareness, this being Alzheimer's Awareness Month, it seems like there's an awareness for everything. This is one of the ones that I applaud. Uh, I thought it would be appropriate to highlight some of the interesting data that I don't think is being discussed enough. Now, some of what I say might not be totally novel to those who have tuned in today, and so for those of you who where this message sounds familiar to you, I bet it's not familiar to other people you know. So if some of what we discussed today is sufficiently compelling, well, spread the news. Help us start to share this perspective that there's more to Alzheimer's than we've classically considered. And so before we dive into this paper, which is, we've shared that link. It's in the Journal of Experimental Gerontology, and it's by a lab. This scientist is Stephen Cunnane, Cunnane. After this Insulin IQ Live is over, anyone who wants to learn more about what we discuss in the next few minutes, I strongly encourage you to continue to dive into Stephen Cunnane's work. It really is remarkable. He's up in Canada, in Quebec, actually, and I'm from Western Canada, and so I tend to have some biases against Eastern Canada, but Stephen Cunnane helps me be a little more magnanimous about it. But nevertheless, the traditional view of Alzheimer's has been that there are two key things that they see in the brains of people with Alzheimer's disease, and that has led efforts to try to reduce these things in the brains, but to very limited efficacy. So in particular, Alzheimer's brains are known to accumulate amyloid plaques, these little kind of proteinaceous plaquey formations, and neurofibrillary tangles. So nerves that would normally be nice and neat and tidy get a little messed up. And so they tried to address both of these, and drugs that have done so really don't improve the disease whatsoever. So really challenging the idea that Alzheimer's is some anatomical disruption within the brain, these tangles or these plaques. And thus, I think we need to have a different perspective, and the energetic perspective comes into play. So let's get to the paper then. What Stephen Cunnane's group did, which is just ingenious, they are using something called a PET scan, positron emission tomography. So basically, by infusing a radioactive substance, and someone doesn't need to think of, like radiation and this is going to poison someone. It's an incredibly low amount. But they infuse, what you can do with a PET scan, PET scan, is infuse a radioactive substance into a person, and then the PET scan will tell you where it's going and the rate at which the body is even breaking it down or metabolizing it, if it's a nutrient, which is what they used in this study. So that's part of the technology that they're using. And interestingly, PET scans can be used to identify cancers, where they can, because cancer cells will typically use glucose at about a rate of 200 times more than a normal cell will. If you infuse a person with a radio-labeled or a radioactive glucose, you see that cancer, that little tumor, will pull in an enormous amount of the glucose, and you see these really dark sections on the PET scan. So it's a very effective way of knowing where are tumors in the body. So the Cunnane group basically used this same technology, but they tracked the use going up to the brain. So they infused radio-labeled glucose, which had been used before, like for example with cancer, identifying the extent of tumors in the body, and they infused a radio-labeled ketone, specifically acetoacetate, which is kind of the mother ketone. In the realm of ketogenic diet and people who are interested in ketones, a lot of the focus is on beta-hydroxybutyrate, which is there's more beta-hydroxybutyrate than acetoacetate, but they're going to be used by the brain both equally well. Acetoacetate is the mother ketone because when it splits, it makes beta-hydroxybutyrate. So all of this is just background. They infused radio-labeled glucose and radio-labeled ketones. And they did this in 3 groups. People who had no evidence of cognitive decline, so that's the control group. The second group was people with mild cognitive impairment, so they were scoring a little poorly on some of these cognitive tests, recall tests, reading novel word tests, and more. And then a group of people with fully diagnosed Alzheimer's disease, so that the cognitive decline had gotten to that point. So pretty clever in splitting it up into 3 groups. And it just highlights the sensitivity, what they're able to detect. So basically, by combining the PET scan with MRI scans, they could detect specific regions of the brain, like different sections of the cortex, the cerebellum, the gray matter, the white matter. They could split it all up into these different sections. And the theme of the study was this. In both Alzheimer's disease and even in mild cognitive impairment, there was a significant reduction in the rate at which the brain pulled in glucose and the rate at which the brain metabolized the glucose. And so there was very much this nutrient-specific deficiency where the brain wasn't using glucose very well. However, in both cognitive impairment and full-on Alzheimer's disease, however, there was no difference across all the groups when it came to ketone uptake and ketone metabolism. So that was suggesting that even though the brains were compromised in using glucose in people with cognitive impairment, they're not compromised in using ketones. And so someone would look, now let me actually, before I go on that, let me mention my own data. We collaborated, this is unpublished, so any scientists out there or people listening that worry about this, it's unpublished, I'm disclosing that up front. It's in the 2nd round of reviews. I'm optimistic it'll get published in a very good journal soon. We collaborated with a lab here at BYU who does a lot of gene analysis, and they had access to samples from human brain. So post-mortem, the person died, and they, before that, volunteered to donate their body to science, and we were able to study their brains. This is from people who died without any evidence of Alzheimer's and people who died with Alzheimer's. And so we just looked at general kind of universal gene expression. All of the genes involved in glucose uptake and glucose metabolism in the brain, and all of the genes involved in ketone uptake and ketone metabolism. And our findings very much support those of Stephen Cunane's. Even though we weren't looking at actual ketone use or actual glucose use, we found that there was a broad reduction in the expression of genes involved in glucose uptake and metabolism, but no significant changes in the genes involved in ketone uptake and ketone metabolism. So adding another dimension to this phenomenon, and this theory that perhaps part of cognitive decline is a result of the brain starving. Now, there's evidence to support this, where you can take people with Alzheimer's disease and give them ketones. Like, for example, the most effective ketone supplement is a ketone ester. You can give someone with full-blown Alzheimer's disease a ketone ester, and you can detect in real time improvements in cognition. It doesn't cure the disease, but it significantly improves it. They begin immediately performing better. And in fact, in one of the case studies published, the person hadn't been able to get themselves dressed for years. And then once they were in deep ketosis, immediately with the supplement, they were able to get themselves dressed. That is a very real blessing and benefit, and suggests very powerfully that looking at cognitive decline through the lens of an energetic deficiency, in other words, the brain is starving, appears to have more legs to stand on than the conventional views, which is that it's a plaque problem or a nerve tangle problem. Now, what could someone do, or what's one of the takeaways here? It's one thing to acknowledge the brain can use ketones, but then the person has to acknowledge that they might not be providing the brain with ketones. As likely everyone knows who's tuning in, the body can only make ketones when insulin is low. And unfortunately, conventional eating is that someone's eating a high-carb diet, lots of starches, lots of sugars every 2 hours. And that's a wonderful way to keep insulin elevated every waking moment of the day. And insulin only starts to come down overnight, maybe around midnight or so, depending on when they eat. And then it would take hours afterwards. Even still, you'd need 16 hours or so of low insulin before you'd start making ketones in any meaningful amount. And yet, well before that happens, they start eating again. So the tragedy here is you have a person who is falling into cognitive decline because their brain is starving, likely because the brain is becoming insulin resistant, and insulin does facilitates some of that glucose uptake, which is why people call Alzheimer's disease insulin resistance of the brain, or type 3 diabetes, which is silly. I don't like that latter term. The former is better, insulin resistance of the brain. So the brain is starting to starve because the fuel that the person is forcing the brain to use, namely glucose, it can't use very well. And the fuel that it's begging for, ketones, the person won't allow to be made. They're not giving the brain the only viable fuel that it is trying to rely on. And the brain will greedily use ketones. The moment ketones start to increase, the brain will shift and start using more and more of its meeting its energetic needs with ketones. So the brain will happily use ketones, and in fact, perhaps prefers it. The tragedy here is, while the brain is starving, the person is, deliberately or not, forcing the brain to starve because they're not allowing the body to get any meaningful amount of ketones. So that's the metabolic classroom as we continue to focus on Alzheimer's disease, and it is worth focusing on. It is a terrifying disease, and indeed one of the two diseases that scares me personally because of a family history. One of the reasons I am an advocate, I have very little worry of type 2 diabetes, frankly. It doesn't concern me. I don't have a family history of it. Alzheimer's scares me, and I want to make sure my brain is fueled. If there's any hint, if there's any potential that my brain is compromised in its glucose use, well, then I'm going to make sure, and I would want anyone to make sure that the brain has that option, that it can be the hybrid, that we allow it to be the hybrid, that it really is shifting between the fuels as they are available. That's the way the brain is built, and unfortunately, the modern diet has prevented it in a way from acting according to its nature.
Wow, that's fantastic. Do any of our panelists have questions for Dr. Bikman about what he's taught us today?
Yeah.
Go ahead, Carly.
Kind of to play devil's advocate, what would be the downside of someone keeping their insulin high by eating carbs and taking exogenous ketones or ketone esters?
Mm-hmm. Yeah, so I'd say the downside is that they will not have the benefits that come from lowering insulin. So that would be a person who would perhaps they'd still be struggling with weight, they'd still be struggling with blood pressure, struggling with dyslipidemia or high triglycerides and low HDL. They may be fueling the brain, but they will by giving the body ketones, but they will continue to exacerbate the compromised glucose use. And so that is a person who would basically be, and I'm speculating a bit here, but ensuring that they need to continue to take the exogenous ketones, which is an expensive habit, unfortunately, especially with the ketone ester, which is certainly the most effective way to do it. That is not cheap. So they would be increasing their dependency on exogenous ketones because they would be continuing to compound the glucose deficiency of the brain while they maintain insulin resistance. And thus ensuring they have to keep taking the exogenous ketone. That's my off-the-cuff thought on that.
And Ben, I asked you that question at Breckenridge with the panel, and they basically agreed that having high levels of insulin and high levels of ketones is not a natural.
Oh yeah, I very much. So I, if anyone had ever said that before me, Rich, I don't know it, so I'm going to claim that is something I've really made an effort to bring to light. The body should not have elevated insulin and elevated ketones at one time. Now, Carly, that doesn't change the fact that someone maybe would still shrug their shoulders and say, oh, well, to hell with it. I want to eat my bagel and drink my ketones, and in the process perhaps fuel the brain adequately, but continue to compound the fundamental problem. But yeah, any listeners that are thinking, well, I'm just going to take the exogenous ketones to be in ketosis all the time and eat whatever I want. That's not the purpose. The purpose of a low carb diet is not to be in ketosis. At least in most instances, anyone listening who's just trying to be overall in trying to improve their metabolic health, really the purpose is to lower your insulin. The ketosis, by my reckoning, is just a bonus. Now, there are some people who need to be in ketosis all the time, like, for example, controlling their seizures. With epilepsy, ketosis is, in many instances, completely, it is the cure. As long as they're in ketosis, they'll never have another seizure. Same with certain people in migraine headaches. As long as they're in ketosis, they'll never have a migraine. So the brain appears to be very susceptible to the lack of ketones. So if someone needs to be in ketosis, then I think there's a reason for exogenous ketones. Or if they're an elite athlete and they are low carb, or not even low carb, and they just want that other fuel to use. But for the rest of us that are doing it for long-term metabolic health and the reduced risk of all the diseases that derive from poor metabolic health, then the point isn't ketosis. The point is lowering insulin.
Hey, Ben, I'm seeing some studies at different universities on the usage of exogenous ketones in Alzheimer's rehab and therapy.
Mm-hmm.
Are they just giving them exogenous ketones, or are they doing both ketones and lowering their insulin?
Yeah. So the only studies that I can think of, which is just a handful of case studies, none that have been sufficiently big. It's just a few little patients here and there. They have used exogenous ketones, ketone salts, or, of course, more effectively, ketone esters. So that's a point of disclosure. Frankly, it'll be good to get some randomized double-blind trials to really state this conclusively. At the moment, we're relying on case studies, which have a very real value. They're just not quite as high impact as a randomized double-blind trial.
Corey, did you have a question?
Yeah. So from this study, it's not really. Maybe I explain this, because to me, it doesn't really show that the brain has insulin resistance.
Nope.
It shows that the brain has a problem metabolizing carbohydrates.
Yep, you're exactly right. This study did not touch on the insulin resistance. When I mentioned that, I was admittedly invoking other data. And I would encourage any listeners, go to Google Scholar or PubMed, and you can just type 3 diabetes, or even, in quotes, insulin resistance of the brain, and you'll find a lot of hits there. So I was admittedly infusing that line of thinking as just or as a potential explanation for the mechanism of why the brain is compromised in its glucose use. But this study, you're right, it did not touch on that.
But regardless, the brain in an Alzheimer's person is having a hard time metabolizing glucose. So is there evidence that people with Alzheimer's have documented insulin resistance other than in the brain? I mean,
Yeah,
okay.
that's a great question. In fact, there was a study out of Finland where they looked at it was 24 or so lifestyle variables, trying to find what were the variables that correlated. It was just correlation, of course, which is about as good as you can get in this case, frankly, because it's not like you could cause insulin resistance in a person, keep them there for 20 years, and then detect their dementia later.
Yeah.
So in this instance, correlation is about as good as it can get in humans. But they found that someone's fasting insulin was more tightly correlated than their age with regards to their risk of Alzheimer's. Isn't that crazy?
Wow.
Now, again, this
awesome.
isn't establishing causality, but the actual p-value, suggesting, basically helping rule out the possibility that it was just random chance, that there really is a meaningful connection there. Fasting insulin had a better, a more stronger statistical value than age did. A pretty sobering observation.
Okay, the geek in me wants to ask this, but is there an animal model for Alzheimer's?
Oh yeah, totally. Yeah. You can find an animal model for everything. In fact, I feel like I could open up a trench coat, Corey, and say, "What do you want? You want an animal model for Alzheimer's? You want an animal model for diabetes? I got whatever you need." So there is one in mice, but the problem is we have to induce the Alzheimer's in these animals, so they're genetically bred to have this type of cancer, or genetically bred to have. So it's really heavy-handed. There's nothing subtle about what we do in the animals. So there are animal models that would allow us perhaps to explore this more mechanistically. But we've published a paper. We never published it. It was a conference presentation that one of my students did, where we induced hyperinsulinemia in a mouse model. So we forced them to have elevated insulin all the time. And we when we pulled out the brain and looked at the mitochondrial function, they were producing less APP. I need to publish that paper.
Wow, that's interesting.
Yeah, and I'm just sitting on that data. But that was a real finding presented at a conference, so I can state it with some confidence.
Yeah.
So this is kind of an unrelated question, but kind of related. A few times where we see people who get into ketosis, they lower their insulin, and they actually end up having a little bit more brain fog than than they used to have when their insulin is high. And I've seen improvements there with exogenous ketones as well as a certain type of magnesium.
Mm.
What do you say?
Yeah, that's a great observation, Carly. So we of course, anyone who's adapted or jumped onto a very low carb diet and forced the body to adapt, we all know that there is a very transient state of kind of lethargy and fatigue, brain fog. And we always say that that's the result of the brain transitioning to relying more on ketones, which does demand that the brain develop a greater population of mitochondria, because you have to use the mitochondria to metabolize ketones. You do not have to use the mitochondria to metabolize glucose, which is why cancer cells like it so much, because they don't want to have to use the mitochondria, or they can't. But so there is that transition. However, it does, in fact, bring up a possibility that the reduction in glucose uptake is not wholly a result of insulin resistance, that there might be a more fundamental problem in a person who's manifesting with cognitive decline that isn't insulin resistance dependent, and thus improving the insulin resistance. I would suggest that it would certainly help the glucose use a bit, but maybe it's not sufficient to overcome it. And so that's a person who would have to rely more on ketones indefinitely, perhaps. If a person, yeah, Carly, so touching on the magnesium, I have no idea how that would become relevant in improving the function of the brain as someone adapts to a low carb diet. So I don't know it. I don't know if that research is out there. It might be, but I would suspect that there's a lot of more questions unanswered than are answered at the moment.
Well, Dr. Bikman, we appreciate you every week when you do the Metabolic Classroom. It's so helpful. And, you and I, a couple of weeks ago after one of our streams, we were visiting about the work that you're doing on Alzheimer's in your lab. And I mentioned to you that I kind of got goosebumps because I thought all the work that you're doing, and we're doing at Insulin IQ to try to reverse what we call the plagues of prosperity. We first think about type 2 diabetes and some of those types of diseases. And yet, what may end up being one of your greatest contributions to this space might have to do with Alzheimer's. I just have that feeling about it.
Yeah, well, thanks. I do think we're on the cusp of fundamentally shifting the paradigm with regards to Alzheimer's, and it's due. We need to. Our ongoing failure to really improve this problem is a huge issue. But you could say the same thing about cancer, but not to go off on a topic. I'll just end it with this thought. I think whenever we have encountered a dead end when it comes to biomedical research into a chronic disease, I suspect the dead end has happened because we've overlooked the metabolic component. And then hopefully we get to that dead end sooner than later to help us start exploring these unconventional therapies that are a result of improving metabolic health that we've gotten so wrong, as we've decimated metabolic health over the previous decades. And of course, it's like I always say, it's the food we eat. It's either the culprit or the cure.
Yeah. Well, thank you again, Dr. Bikman. We really appreciate it. And for our viewers, whether you're watching on YouTube or on social media or on our website, be sure to go to insuliniq.com. Be registered on our site. It's free, and it puts you in contact with all of the research that Dr. Bikman's going to be doing. It gives you the opportunity to share his research and our streams and our courses with those you love, with friends, family, coworkers, neighbors. And we can all get smarter and try to reverse some of these plagues of prosperity. So thank you again, Dr. Bikman. That was really great.
Yep.
Alzheimer just affects everybody, doesn't it?
It
doesn't, not necessarily first person, but everybody knows someone has a loved one, it's really amazing. My aunt just died and she had Alzheimer's, and it's such a big area that affects everybody. And thanks, Dr. Bikman. That's awesome.
Yeah.
Yeah, you bet. Yep.